Hi, Mr. Ham here again. In this video, I want to concentrate on the spaceship. I want to make our spaceship look more like a ship and add an angle so to allow it to kind of turn based on key presses. And to be able to do that, you will need to understand vectors. So let me explain to you what a vector is as best I can, as quickly as I can, really. So this is not a clock. This is just a circle. And I put an arrow going that way. Now this is representing a vector, and what a vector is it has some kind of angle associated with it. So this one's rotating, you know, so this one has the angle like so, right? And we want, I'm going to take this as its reference, right? But I could, you know, rotate this. So I could then rotate this way, and then the angle would then be from here to here, which I'll keep for now, but to demonstrate. And a vector also has some kind of magnitude. We call it I guess the length of it. So some kind of length, and we call this magnitude. We call it magnitude. We call it magnitude, right? And this one's its angle. So we could say, you know, it's of a particular magnitude at some angle, right? And the way our spaceship's going to work is we want to be able to rotate this way and this way. We want to be able to turn. This one's turn right, and this one's turn left, right? So we want to change the angle. But the issue is our game doesn't take angle. It only knows to position our object at certain points and to move it this way or this way, right? So we need to resolve these vectors into its horizontal and vertical components. We need to somehow convert the vector so that we can get this distance, this particular distance here, and this particular distance here. So we need to divide into two components, this kind of vector into two components, and then we can use this one to make it to travel, to tell it how to travel in the horizontal direction, and use this one to tell it how to travel in the up and down direction. And to do that, it's basically trig. So if this was the hypotenuse, if you want to get this one, which is the adjacent, you cos the angle, and then you multiply by the magnitude. So this is a little bit of maths, a little bit of high school maths. And if you want this component, the one going up, the vertical component, it's the magnitude multiplied by the sine of the angle. And then we can use these to tell it to move at a certain rate in this direction and this direction, which simulates it moving in some diagonal. So if I'm moving at a certain rate in this direction and then another rate in this direction, it will travel in that direction. It will travel in that diagonal direction, right? So that's pretty much a vector, and that's what we need to do. We need to convert our angles and our magnitudes into our horizontal and vertical components so that we can slot it into the game and animate it. Because, as you can see here, if I go back to our base game, this is our horizontal and vertical components, and it doesn't have angle. So we need to convert angle into these two things, right? So that's pretty much it. Hopefully that's enough for us to move on. So now let's go into our spaceship, and let's give this spaceship an angle. And we'll put this into the spaceship because the asteroid doesn't need this. I know the projectile needs it, but we'll put it into projectile as well if we need to. Or we could have done a two-level inheritance, but I don't want to do it. All right, so so we've got an angle here, and we need to kind of break these up into its horizontal and vertical components, right? Do we have speed? We have vertical speed and horizontal speed. I don't need those anymore, but what we do is we have the magnitude, the speed mag. We'll call it speed mag. So this is the speed magnitude. So we're going to take this magnitude as a speed, or rather velocity, isn't it? Huh? Yeah, speed mag, whatever. As single. And we need to resolve these into horizontal and vertical components. So we need some function that does the resolution for us. Some function does the resolution. So we're going to add in a function. We're going to add in a private function, private function. And to be honest, I'm just thinking maybe I should put this into a base class. So we have, so even though the asteroid doesn't use it, you know what? That's what I'll do. I'm going to put these into the base class. Even though the asteroid doesn't use it, I'm just going to add it in there. And in the base class, I'm going to give it a little math function that will do the resolution for us. So we can call this, and we'll make it public because you know all the others may need it, right? So public, we won't. It's not overridable, but we'll go public function sub. We'll go public sub. Resolve vector, call it that, and then it takes in some kind of speed magnitude. We'll just go magnitude, and it takes in some kind of angle as, what am I doing, string, single, because there's a floating point. And we take in some kind of angle, and then we're going to resolve it. In sub, we're going to resolve it. And then we're going to place it into these two. So we'll go me.hspeed. Now the hspeed is the cosine. So it's magnitude multiplied by cosine, math.cosine of the angle. And this is going to be magnitude times math.sine of the angle, and this is going to be our vertical speed. So every time we give this and this, it calculates our horizontal and vertical speed, and then it gets used here, and it will move at a certain angle, right? We could try that. So that's kind of working. Let's see if that works for our ship. So what we do here is we can give our ship, we can give an angle to our ship. Let's give it, say, 45 degrees, and then we'll give it a speed as well. I don't have speed here, do I? All right, fine. I'll just go resolve. Do we have resolve? Our resolve vectors here. We can shove in our magnitude. We'll make the speed 3, and we'll make the angle. We'll put me.angle since I'm using it from here. So it resolves. So it'll resolve that, and then it should work. It should go at a 45-degree angle. There you go, and it's upside down because the coordinate system for Windows is positive going downward. That's why. So, well, that's annoying. So what I guess we could do is multiply this by negative. Maybe multiply this one by -1. Do a minus on that. Put a minus there instead. And it should go 45 degrees. Yep. and let's make that 90 degrees. 90 degrees should be going up. So I'm just showing you here, this is 45 degrees, 90 degrees, 180, 270. All right, so it's starting from here and going around like that. Oh, here's another issue. Our angle is should be in radians. So if I'm using this and I'm putting 90 in here, I should times this by pi on 180 times pi. And I haven't explained to you what radians is. I wonder what the time is. Alright, I got time to explain what radians is. Alright, so what radians is if you have an angle, what it is I'll just put it in our circle. Right, what radians is it's a measure of rotation, just like degrees. The only except we just quickly this is 0, so okay, is that working? Okay, so this is 0 degrees here. This is 90 degrees here, in degrees, right? And this is 180, and this is 270, right? And then 360. And what radians is we assume that this radius is 1, whatever, 1 centimeter, it doesn't matter, 1, and then we work out the circumference. So that circumference is 2 pi times r, and since r is 1, then the distance around this circle is 2 pi. The distance around this circle is 2 pi. So really, 2 pi is equivalent to 360 degrees because it's all around. So that means if I went halfway, it'll be 1 pi. So from here to here is 1 pi, because going all the way around is 2 pi. So going and stopping here would be pi. So 180 is equivalent to pi. And then 90 is equivalent to pi and 2. So that's what radians is. Radian, and we'll put little c's here to represent radians. So radians is just another measurement of angle, right? So instead of saying 80 degrees, it's pi radians. Hopefully that's giving you some background on radians. So that's what we need to do. Let's run that again, see if there's any issues. 90 degrees, that's good. Let's go with 45 again. Yep, all good. Alright, so no problems there. Alright, no worries. I guess that's it for this video, so I'll see you in the next one.